Hey, also in this video, I'll be going over the 2024 NHT physics exam, and I'll be doing the multiple choice for this section. So without further ado, let us get started. So question number one, electric and gravitational forces have variety of properties. Which one of the following best describes the attraction and repulsion properties of electrical and gravitational forces? So electric forces can attract and repel, but gravitational is only attract. So the correct option for this should be option A. Okay? Two positive isolated charges, each carrying a charge of plus q, are separated by a distance d. Exert an electrical force F on each other. To decrease the electrical force to F on 5, the separation of the charges would have to change too. Okay, so the formula will be F equals to K Q1 times Q2 on the R squared. Okay, now charges are the same, so we can simply write this as KQ squared on R. Okay, now what I like to do with this is I just substitute. So let's say we want force to be 1/5, right? So rather than writing all of the proportionality and stuff, what I'll do is I'll just take F as 1 on 5. I'll show you what I mean. Okay, but before we do that, we can see R squared. But before we do that, we can see that the first term, like the numerator, is just going to be a constant. So F is indeed going to be like that, right? So now, rather than actually solving for the inequality, what I'm going to do is I'm just going to substitute F as 1 on 5. So 1 on 5 is equals to 1 on R squared, because it's F on 5. So we want the force to be 1/5, right? So now we just solve for R. So R is equals to square root of 5. So hence, our answer will be C for this one. So this is what I use to solve for, these proportionality questions, because sometimes they do get challenging. So yeah, this is just my way of solving them. Okay, hopefully this made sense. So question 3, two charged plates with equal and opposite charges are placed together as shown in the diagram below. A distance of 2 millimeters separates the plate. The potential difference between the plates is 6 volts. Which one of the following is closest to the electric field between the plates? Okay, so we can use E equals to V on D for this, right? So voltage is 6 and distance is going to be 2 millimeters. So that would be 2 to the power of minus 3, because we had to express it in meters. Okay, and let us put this on our calculator real quick. So 6 on 2 times 10 to the minus 3. Okay, so I get 3 times 10 to the 3. Okay, and our answer would be this, option D. Okay, two satellites orbit around the Earth, have the same mass, but are traveling at different speeds. This means that, okay, so velocity is equals to square root of gm on r, right? So G and M are constant, okay? Because, well, same mass. So we can express this as like so, okay? But they are traveling at different speeds. So they will have the same, they orbit Earth at different radii. Yes, that is true. Answer is most likely going to be the same one, like option A. They will have the same kinetic energy. No, because they are traveling at different speeds, so not really. They orbit Earth with the same period. The gravitational force extended on them by the Earth will be the same. Okay. Yeah, the most convincing one I can see right now is option A. I'm just gonna go with that. Okay. Next question. So question number 5. Students construct a simple DC motor using 2 magnets, a single coil of wire, a split ring commutator, and a battery as shown in the diagram below. The coil turns clockwise as seen from the battery end of the DC motor. Which of the following best represents the polarity of the magnetic poles P and Q? Okay. So using the right hand slap rule here, let me just quickly label which side the current is going. So it's going from positive to the negative. So it's going to go like that. Okay, so now if we just use our right hand slap rule, so P is going to be south. And this one going to be north. Yeah. Okay, so option B. Okay, we can easily cancel out option A and D because, well, they can't be of the same polarity, or else it won't rotate, the coil won't rotate. Okay. Alright, yeah. So question number 6. The diagram shows two coils of conducting wire wound around an iron core. Coil 1 is connected to a battery and a switch. Initially, the switch is closed and the current flows through coil 1. There is an ammeter connected to coil 2. Okay, the switch is now opened. Which one of the following statements best describes what happened to the reading on the ammeter? Okay, so it remains at a constant non-zero reading. No, that can't be true. It moves from non-zero reading to a zero reading. Yes, it moves from a zero reading to a non-zero reading and then back to a zero reading. Absolutely it does. So it can't be option B either, because C does sound a bit more detailed and correct. It moves from zero reading to non-zero reading and remains at non-zero reading. No. Answer C is going to be the one, because we have to consider the change in flux. Now, switch is closed, so the current is flowing, the flux is zero, and as soon as the switch is now opened, so there's going to be a slight change in magnetic flux, so it's going to show some reading, and then it's going to go back to zero because the change in flux, right? So yeah, that's the answer. Hopefully that made sense. Okay. Question 7. An ideal step-down transformer has primary to secondary ratio of 6:1. The input power at the primary is 40 watts and input AC and has... Wait, what? The input power at primary is 40 watts and the input voltage is AC and has RMS value of 240 volts. Which one of the following is closest to the output current of the transformer? So, we do know that because it is an ideal transformer, input power is equals to the output power. So that means V1 I1 equals to V2 I2. Right? And what are we finding? We are finding the output current. So we are finding I2. So let's make that the subject. So I2 would be V1 I1 over V2. Okay. Now, we know the value of V1, which is 240, but we need to find the value of V2. So since we are given the ratio, we can do that as well. So we can use N1 on N2 is equals to V1 on V2, right? So our V2 is equals to V1 N2 divided by N1, which is going to be 240 times N2, which is 1 on 6. So our V2 is going to be 40 volts. Now it makes sense because it's a step down transformer, so value has gone down, makes perfect sense. Okay? Now, V1 I1, doesn't that look familiar? That is just P1, right? So we know that P1 is 40 watts, so we can say 40 divided by 40. So that cancels out and gives us a current of 1 amp. So answer is going to be B for this one. Okay? Question number 8. The graph below shows the variation in magnetic flux through a coil as a function of time. Which one of the following best represents the induced EMF in the coil as a function of time? Okay. So we know that EMF is equals to negative of change in flux over change in time. Or you can just say negative dflux on dt. Okay, same thing. So just by using some mathematical knowledge, we can identify, hopefully, that this is a sine graph. This looks like a sine graph at the very least, okay? Now, I just think of it this way. So we just have to basically differentiate this graph over here. Now, if this is sine graph, for example, if we differentiate sine, we get cosine. And how does cosine look? It's going to look something like this, right? And since it's negative, we just have to flip it. So basically, the starting of the EMF graph should be like this, something like that. Okay? So it can't be option A for sure. Option B, yes. It can't be option C either, because that is just the same graph, okay? Can't be option D either, because it's just simply negative. It's just reflected. just flipped across the x-axis, so it can't be that. So answer is going to be B for this one. Okay, hopefully this made sense. And yeah, okay, so just think of this as a sine function because it does look like a sine of x, and if you differentiate that you get cosine, but since we are looking for the negative differentiation, it will become negative cosine, and negative cosine looks like this. Okay, hopefully this made sense. All right, let's move on to the next question. So a soccer ball is kicked and it moves through the air from left to right as shown in the diagram below. Point P is the highest point of its flight. Air resistance is not negligible. Okay, so it is not negligible. Which one of the following diagrams best shows the direction of the resultant force on the ball at point P at the maximum height? So if it was negligible, the force would just simply be pointing down, right? Am I right? Okay, but since we are taking into account the air resistance this time, have a look. So the ball is going to be the ball's velocity is going to be perfectly tangent at this point, right? So that means our air resistance is going to be pointing this way, right? So if I were to draw force vectors, so one of them is going like this, which is just the gravity. Then there is the air resistance like that, okay? Now, if I were to draw a resultant vector of these two, we would get something like this, slightly to the left. So it looks like option D is going to be our answer, okay? All right. The Global Positioning System GPS satellite orbits Earth at an altitude of 35,786 kilometers. Assume that its orbit is circular. Which one of the following statements is correct concerning the momentum and the kinetic energy of this satellite as it moves around its orbit? So, both kinetic energy and momentum are constant? Absolutely not. Both kinetic energy and momentum vary? No. The kinetic energy is constant and momentum varies. That is right. Okay? The kinetic energy varies and the momentum is constant. No. So the reason why this is the correct answer is because remember that kinetic energy is a scalar. Okay? It doesn't have a direction. However, momentum is a vector quantity and it does have direction. So velocity here would be going like this, and then at this point velocity would be going like that. So as you can see, there is a change of direction in the velocity, and hence momentum will not be constant. Like the magnitude may be constant, but not the direction. So momentum does vary. Okay, so that's why option C is going to be the correct answer for this one. Yeah. Okay. Yeah. All right. Cool. So, which one of the following is not a version of a postulate of Einstein's special theory of relativity? Speed of light does not depend on the motion of the source. The laws of physics are the same in all inertial frames. The speed of light does not depend on the motion of observer. The speed of light is the same at Earth's surface as it is in all transparent materials. First three sound right. Option D is not one of the postulates. Okay? A small toy car travels on a track with a vertical circular loop starting at point X as shown in the diagram below. The diameter of the loop is 0.4 meters. The minimum speed at which the car must be traveling at point Z in order to continue to touch the track is closest to. Well, we can simply just use the formula. So V is just going to be the radius times the gravity. So the square root of radius times the gravity. Okay? So our radius is, what is our radius? So the diameter is 0.4. The radius is going to be 0.2. times the gravity, so 9.8. Let me put that in the calculator real quick. So we will get 0.2 times 9.8. 1. So I get 1.4. So our answer is going to be 1.4. So option C looks the correct one. Okay. Question number 13. Belinda is a child with a mass of 30 kilograms. She runs along the grass and then slides on the horizontal plastic water mat. She comes to rest after sliding 6.5 meters. The frictional force between Belinda and the mat is constant and has a value of 50 Newton. Which one of the following is the closest to the work done by the plastic surface on Belinda, causing her to stop? Well, this is just simple frictional force question. So work we know is force times the distance, right? So the friction force is constant, which is 50 Newton. And it took her how many meters? So 6.5 meters to that. And just put that in the calculator, and this should give us the answer. So 50.6.5, 3.25, oh, well, times 10 to the power 2. So 325, so A. Okay? All right, Helena is riding down a hill on her bicycle. It is a very steep hill, and she has the brakes of her bicycle partially on so that she travels down at a constant speed of 20 kilometers an hour. The combined mass of Helena and the bicycle is 60 kilograms. Which one of the following is the closest to the frictional force acting on the bicycle due to Helena's braking as it moves down the hill? Okay, so it goes at a constant speed. Let's draw a diagram for this real quick. Okay, so let's say that this is our inclined plane. And let's say that this is Helena, and her bicycle. So this should be like that. And our normal force like this. Like that. Well, it's not exactly perpendicular to the plane, but okay, this looks very wrong. Let me fix that real quick. This should be going straight down like that. Okay, that looks a bit more promising. Okay, now we have a frictional force opposing like that. Okay, and she travels on at a constant speed of 20 kilometers an hour. So basically, sum of forces has to be 0, essentially. Yeah, because if the speed is constant, then yes, acceleration is 0. Okay, so yeah, in that case, if I draw the components of this is mg. Well, that's a bad color. So mg, if I draw, okay, that's a bit too much. Yeah, like that. So I guess in this case, our friction force is just going to be mg sine of theta. So like this component over here, except it's in the other direction, right? So we will get 60 times 9.8 times sine of 30 is just half, but I'll still write it down like this. Okay, so 60 times 9.8 times sine of 30, and that would give us 294. Have I done any mistake? No, I haven't. Okay, which one of the following is the closest to the frictional force? I guess if this is 294 newtons, I guess the closest one would be 300 for this. Okay? Yeah. Okay, looks correct to me. Okay, an ambulance with its siren sounding is traveling with a constant velocity. So this is the key part here. Along the straight road. Initially, the ambulance passes the marker X, then a stationary observer, so the observer is not moving either. Whoa, what was that? And finally, a marker Y, as shown in the diagram below. The observer is located midway between the two markers X and Y. Okay, so if the siren emits the sound with a constant frequency as well, which one of the following best represents the frequency of the siren as measured by the stationary observer? Okay, so yeah, if it's constant frequency, then I think A would be the best choice here. Okay, because as ambulance is coming closer to the stationary observer, the frequency will be higher, and then as it's going away from the observer, the frequency will drop. And since the velocity is constant, frequency is constant, it's going to be option A for this one. Okay? All right. So, which of the following correctly lists the different region of the electromagnetic spectrum in order from the longest wavelength to the shortest wavelength? So it is going to be radio, microwave, and then infrared, visible, ultraviolet, and then X-ray. So what was it? Radio, microwave, infrared. Okay, I think option D. Yep, option D. All right, so a ray of light passes from a block of crown glass with a refractive index of 1.52 and then through a block of flint glass with a refractive index of 1.63 as shown in the diagram below. While traveling within the flint glass, the speed of the ray of light is closest to. Okay, so in this case, we can use the formula that N is equals to C on V. Okay, so our V is equals to C on N. So that will be 3 times 10 to the power of 8 divided by N, which is 1.63. And let's just put this on calculator. So 3 times 10 to the power of 8 on 1.63. So that is giving 1.84 times 10 to the power of 8 meters per second, of course. So option B. Okay. The graph below shows the relation between the maximum kinetic energy of ejected photoelectrons and the frequency of light F used to irradiate two different metal surfaces. Light frequency of this is incident on both metals. Compared with the fastest photoelectrons emitted from metal 1, the fastest photoelectrons emitted from metal 2 will... Okay, wait, what? So the graph below shows the relationship between the maximum kinetic energy of ejected photoelectrons and the frequency of light. Okay. Okay, two different metal surfaces. Light frequency is this. Compared with the fastest photoelectrons emitted from metal 1, the fastest... okay, so we do know that EK is equals to HF, take away the work function, right? So H and F are both constants, right? Because, well, light is this for both, and H is just a constant itself. Okay, so that means that EK is proportional to the work function. Okay, now if I were to extend these lines like so, for example, and like that, okay, as you can see that the work function of metal 1 is greater than metal 2, right? So that means that is greater than that. Okay? And if that's the case, then that means EK of metal 1 has to be greater than EK of metal 2, right? So that means if energy of metal 1 is greater than energy of metal 2, then that means the velocity from metal 1 would be greater than velocity of metal 2. So V1 has to be greater than V2 as well, right? Does that make sense? So because work function of metal 1 is greater than work function of metal 2, energy of metal 1 will also be greater than energy of metal 2. And therefore, velocity of metal 1, like, well, not metal 1, but velocity of the fastest photoelectrons emitted from metal 1 would be greater than fastest emitted photoelectrons from metal 2. So the answer would be that V2, or the fastest photoelectrons emitted from metal 2, will have a lower velocity. So option A will be our answer. Okay, hopefully this made sense. So a laser has power output of 30 milliwatts and emits light with a wavelength of 650 nanometers. How many photons does this laser emit per second? So let's find the energy emitted by one photon, so hc on lambda. So we will have 6.63 times 10 to the minus 34 times 3 times 10 to the power of 8 all over the wavelength which is 650 times 10 to the power of 9 because it's nanometers. And let me put that on my calculator real quick. So I'll get 6.63 times 10 to the minus 34 times by 3 times 10 to the 8 on 650 times 10 to the 9. Okay, so I get 3.06 times 10 to the minus 19. Just making sure I've typed it correctly. Yep. Okay, and this is the energy. This is the energy emitted from one photon. So now we have a power output of 30 milliwatts. Okay, so what we do 30 times 10 to the minus 3 on 3.06 times 10 to the minus 9. So if I were to do that, let me just do that on my calculator. So I get an answer of 9.8 times 10 to the 16. So it is option C for this one. The electron double slit experiments provide evidence for the wave nature of matter. Okay, option D. All right. Yeah, so that's that for the multiple choice section of the VCE NHT 2024 physics exam. Hopefully you guys found it useful, and I'll do the short answers in a bit. So I'll see you in the next video. Bye-bye.